So we're going to use some vocabulary here for when you actually wind up drawing some of these auxiliary lines. So if here, for instance, we're asked to draw a segment from A that's perpendicular to B, there is only one possible segment that we could draw. That is considered determined. If that is a determined drawing, that is, there is only one possible way to draw that line. It's unique. Unique. There's only one possibility. And you like determined drawings because then there's no ambiguity. There's only one possible way to draw the diagram. Undetermined is when there are many possibilities, and often if there are many possibilities, then there's an infinite number of possibilities. So if we were asked to draw a segment from A to the side BC, well, here are just 1, 2, 3, 4. Here are just 4 of the infinite number of possible line segments that can be drawn from A to BC. So that's considered undetermined. And then overdetermined means that your description is so specific that there are no possible solutions. There's no possible line that can be drawn that can meet all of the characteristics. So here, if I was asked to draw a line segment from A perpendicular to BC, which is what I was asked up here, and that bisects BC, there's no line that will both be perpendicular and bisect BC. So that's considered overdetermined. There's no possible drawing or solution or segment that can be created that can meet all of the criteria. All right, so here we're going to have, since this is going to be a definition, we're going to look at the if-then and then the if-then reversed here. So if two sides of a triangle, this is within a single triangle, not across multiple triangles, in a single triangle, if two sides of a triangle are congruent, then the angles opposite them are also congruent. So if this leg and this leg are congruent, this is an isosceles triangle, which means this angle and this angle, these are the angles opposite the congruent sides, are also congruent. So we would also read that, the base angles of an isosceles triangle are congruent because the legs are congruent. So this is, if the sides are congruent, then the angles. In this statement here, it's if the angles are congruent, then the opposite sides are congruent. So if I'm told I have a triangle and there are two angles that are equal, I would say, oh, those are base angles. They're equal. Then the opposite sides will also be congruent, which would make this an isosceles triangle. Now there's one last kind of triangle, and that's an equilateral. Equilateral means all sides are equal. And equiangular means all angles are equal. So in an equilateral triangle, if all three sides are the same length, that means all three angles have to be 60 degrees and are also the same length. That's an equilateral triangle. All the sides are the same length. And that would mean, we've already learned this one, that all the angles are 60 degrees. And the last definition is perimeter. Perimeter is the distance around the outside of a shape. In this case, the perimeter is the distance around the outside of the triangle. So my perimeter would be the length of side A plus the length of side B plus the length of side C. Add up the length of all three sides. That's considered perimeter. And then in your book, they have this nice review of everything that we talked about. There's a lot to talk about with triangles, but talking about the scalene, isosceles, equilateral, acute, right, obtuse, and the different properties for each of those types of triangles.